Watch the video clip showing the displacement reaction between a magnesium strip and copper sulfate solution. What do you notice? Copper is formed and part of the magnesium has corroded. Which metal is more electropositive? Magnesium is more electropositive than copper. Can we use this property to control metal corrosion? At the end of this lesson, students should be able to generate ideas on the use of other metals to control rusting. Explain with examples on the use of a more electropositive metal to control metal corrosion. Explain with examples on the use of a less electropositive metal to control metal corrosion.
We shall study the effect of some metals on the rusting of iron. The metals chosen are magnesium and zinc, which is more electropositive than iron, and the less electropositive copper. Iron and iron metal pair is set up as a control. Start each video clips by clicking on the captions. Watch each of the video clips. Record your observations in the table given. Study the table that you have filled in and key in the answers in the blanks of the statements. Click on the check button when you are done. Fill in the new column based on the observations in the table. You can also check by studying the iron nails in the laboratory activity. Click on the check button when you are done. Now, complete the statements by keying in the correct answer. Click on the check button when you are done. Study the animation clip on how rusting, which is a type of metal corrosion, takes place. Based on the animation clip, click on the statements that are true for rusting to occur. Click Check when you have finished. How can we control rusting using other metals based on the statements? Key in your answers in the table. Click Compare when you are done. Prevent water and oxygen to come into contact with the iron metal surface. Use of metals less electropositive than iron to cover the iron surface completely. Prevent the iron metal to become the anode and thus prevent the formation of iron-2 ions. Using metals more electropositive than iron will make the iron metal a cathode instead. Iron-2 ions will not be formed. Study the chart shown. Rusting, a form of metal corrosion involving iron, can be controlled by using less electropositive or more electropositive metals. Click on each of the 4 examples to find out more. Metal cans that are used to keep food such as sardines are made from the iron metal plated with tin. How does tin prevent the metal iron from rusting? Key in your answer in the box provided. Click Check when you are done. Tin is less electropositive, therefore less reactive than iron. The layer of tin prevents water and oxygen from coming into contact with iron. Gold-plated microprocessor chip uses a thin layer of gold to prevent the copper beneath from corrosion. How does gold prevent the metal copper from corrosion? Key in your answer in the box provided. Click Check when you are done. Gold is the least electropositive metal, therefore less reactive than copper. The thin layer of gold prevents water and oxygen from coming into contact with copper. The magnesium blocks attached to the ship's hull is used to control rusting of iron of the hull. How does the magnesium prevent the rusting of the iron hull? Key in your answer in the box provided. Click Check when you are done. Magnesium is more electropositive. Therefore, magnesium ions will be formed rather than iron ions. The iron metal will be the cathode and rusting is prevented. The magnesium blocks attached to the iron pipe is used to control rusting of the iron of the pipe. How does the magnesium prevent the rusting of the iron pipe? Key in your answer in the box provided. Click check when you are done. Magnesium is more electropositive. Therefore, magnesium ions will be formed rather than iron ions. The iron metal will be the cathode and rusting is prevented.